In part 2 of this tutorial series, we will set up the input controls and forces necessary to slide the burger with control. Also, we will be making some further tweaks to the physics of our burger to get a more desirable result from sliding. Now, the last thing that we can do for our in part of setting up our burger rigid body is that we want to allow our burger to move this way and this way, up and down, left and right, because we're going to be sliding our burger on the x-axis. We don't want our burger to fall backwards on the z-axis. So we'll just freeze the z position, and for rotation, we want our burger to be able to rotate this way, and that's pretty much it. We don't want our burger to rotate this way or this way, just on that kind of side-on direction. So we'll freeze everything except the Z rotation. And now that that is set up, we can start looking at creating the controls to slide our burger or slide our slider. So for that, we will need to go into our burger controller script. We can get rid of these lines here. And rather than using the start function, we're actually going to use the awake function. And the reason why we need to use the awake function is because every time we need to reset the burger, if the player fails to slide the burger onto the goal, we're actually going to be destroying that burger and creating a new one. And if we were to call this in the start function, then it would only be called for the burger if the burger is existing at the start of the game. But for every other burger that we create, the start method won't be called. So we need to make sure that awake is called, because we want this method to be called every single time we create a new burger. So it says here awake is called when the script instance is being loaded. So first of all, we will need reference to the rigid body, and we can just make that a private rigid body and call that RB. And because RB is already a component that's attached to the same object as the script, we can just simply say rb.getComponent rigid body. And our rigid body is what we will be applying our force to. Now, the way that we are going to be calculating user input is that we're going to, the user is going to touch, put their finger down on the phone screen anywhere, and they should be able to put their finger anywhere, and then they're going to drag their finger to the left, and then the further they drag their finger to the left, the more power is going to go into the slide. But then if they bring their finger to the right, it's going to reduce the power. So a way that you could achieve that is just by simply, when the player touches the screen, we just get that position, and then as they drag their finger, we just keep track of the distance between where their finger is now and where their initial touch was. But the issue with that is that we want there's two things. We want our player to not have to drag their finger across the whole entire screen to be able to get maximum power. We may only want them to have to drag their finger, say, a third of the screen distance. And so what will happen is that we will say, okay, well, let's figure out what is a third of the screen's width, and then once they have dragged their finger 1/3 of the distance of the screen, then that will be at max distance. But any further than that is going to be not counted. We just have to limit the value to the maximum power. But then the issue there is that when the player drags their finger back, the power is not going to go back down until they have brought their finger back to the until they've brought their finger back to where the distance is less than the maximum distance that was required to achieve the maximum power. So it's kind of hard to explain until you actually see it yourself. But let's see if I can actually create a little example here, just with Photoshop. Okay, so let's say this is your screen, and let's say we want the player to only have to, I might use that a bit smaller. Let's say we want the player to only have to drag this far of the screen to be able to achieve maximum power. So maximum power would be a value of 1. So 0 would be here, and then 1 is here, right? And so then what happens is the user will then touch here and then drag their finger. So here would be value of 0.5 or half. And then let's say the user's dragging their finger, so up to 0.75, 8, 9, and then up to 1. And then if they keep dragging their finger even further, it's going to be it's going to be over 1, but we have to limit it at 1. Now they can just keep dragging their finger because they want to try and get more power out of their shot, out of their slide. So then, but if they want to reduce the power, they're going to be moving their finger back. And as they're moving their finger back, then the power is actually not going to go down until they reach this point here, before their power starts going back down to 0.9, 0.8, 7, 6, 5, so on and so forth. So that is it's not a very how can I say, it's just not the most user-friendly kind of approach. It is the simpler, more intuitive approach from like a programming perspective. But what we're going to do is that we are going to figure out where their touch position is. I'm going to say, okay, they touched here. And then what we're going to do is we're going to look at the next frame where their touch position is, and then we're going to look at the distance between the touch on the first frame where their finger position is. So we'll record the initial the initial position of the first touch, And then from there, we're going to compare that where the first touch is on the first frame to where their finger is now on the next frame. And then we'll look at that distance and then we'll add it. And then we'll look at where their finger is on the next frame, look at that distance and keep on adding it. And so then we can call this, you know, the delta, which is like the difference. And what we're going to do is we're just going to keep on adding for each frame the distance between the current position of your finger and where it was last frame. And so then what that's going to do is that even if you make it past, you know, the maximum distance, right, and you keep on bringing your finger further and further above, right? Now say you get to this point here. Now you know, so if you then move your finger back, we're always checking the distance. So what that's going to be is that's actually going to be a negative that's going to be a negative direction, which is going to then start reducing our power, which means we don't need to drag it all the way back to this point here before the value starts going down. But it'll make a lot more sense once we implement it. Now, something about input for mobile devices is that we can actually use, when we're programming, we can use mouse position and mouse input. And then when we build it for our Android device, it will basically translate our finger touch input as mouse input. So in our update, we will just need just our simple input. So if, and then we want input dot get mouse button down. So 0 is left click, 1 is right click, and 0 is going to be touch. And so this is when the player will, you know, initiate the first touch. And then while that's down, because we know that because we will be getting our input dot get mouse button, so this is going to return every frame while it's down. We can count on the mouse being already down and this already being called before we start calling this. Yeah, so this method is going to return true during the one frame when the player touches down on the screen. That's when we store the position. We call that like the first touch position. And then get mouse button is going to return every single frame while the player has still got their finger down. And that is when we're going to be calculating the distance and the position delta and all of that. And then the final input check, we will want to check when the player lifts their finger. Dot get mouse up 0. And that's when the player releases their finger, and that's when we want to slide the burger. So let's start off by recording the first touch position. So for that we will need a private vector2. We'll call that first touch pos. We're wanting a vector2 because our touch position will be a x and y value. And then we just want to assign our first touch position. We want to assign it the input dot mouse position. Save that. And in this if statement here, while our mouse is down, we want to start calculating the distance from our first touch position. So we will need our method, which was called, we need a private float, because this method will return the float, which will be the delta, and we can just call this get x delta. So x, we can say get x pos delta. Yeah. And get x pos delta. So get x pos delta is going to have a float called delta, and the delta will be the distance between the last touch position from the previous frame and the current mouse position. So we need to be recording our last touch position, and I mean we can even state this here if we want. We can say private float last touch pos, and so it will be so we should say x last touch pos x, because we're only dealing on that one axis, and we'll say last touch pos x minus input dot mouse position dot x. And then now that we have stored our delta, we can then now update our last touch position to equal input.mousePosition.x, and then just simply return delta. So then the next frame, when we call get xpos delta, it will have saved the x position from this frame. So the next frame, it will compare the current position to the position from the last frame, and then once that's calculated, we save it, and then save the new position, and then return delta. So then the next frame, when it's called, because this is called every single frame, and as you can see here, it says here returns whether the mouse is held down, and this returns every frame. Update is called every frame. And actually something that if you want to do is if you want to get an idea of how mouse position is all calculated in terms of, like, you know, where the bottom is and the top and the left and the right in update. And this is a great way to get to know Unity. If you want to experiment, you can debug log these sorts of things. And we can just debug.log input dot mouse position. And then if we just run this, since we have a null reference, oh, sorry, it should be RB equals get component. So now you can see here, if you look, we'll take that out of collapse. Okay, there we go. So you can see when I bring my mouse all the way to the left of the screen, it's basically 0. And then when I bring it all the way to the right, it is the whatever the screen width is in pixels. And then the top is 500, so the maximum screen height. And then move our cursor down to the bottom is 0. So the bottom left of the screen is basically, it's hard for me to do it like this, but it's basically 0, 0. Now, the reason why we are subtracting the current mouse position from the last or previous touch position or mouse position is because as the user drags their finger to the left, we want the power value to go up. And because the left side of the screen is going to be 0 and the right side is the screen width, then our new mouse position is, when we're dragging it to the left, is going to be less than our previous touch position. So this number will be smaller than this number. So when you subtract a small number from a bigger number, then the value is going to be positive. And because we are continuously adding delta, that value is going to be increasing as we drag to the left. And then when we drag to the right, the value is going to be negative, so it's going to decrease. So that's why it's important to know which, where is the 0? Is it in the bottom left, or is it in the bottom right, or top? I mean, bottom and top doesn't matter so much in this circumstance, but in this situation, it's important to know whether it's 0 on the far left or 0 on the far right. And as you saw in our debug, it is 0 in the far left. We can get rid of that debug now. You could probably also Google that, and you could find information about that as well. So now to calculate our distance, we'll need to be able to store that in our in a private float. Call that dist, and then we will need a public. Actually, no, we'll make that private for now. A private float max touch dist, but max touch dist is going to be calculated, and we're going to use a fraction. So if you want to, so we'll be using a public float called max touch fraction. And if you wanted to make it all, user friendly and such, for in the inspector, then what we can do is we can add a range tag, or range attribute, and the range for that will be value between 0 and 1. 1 being 100%, and 0 being 0, and 0.5 being half, 50%. So, and just put like that so we can save space. And don't want it on 2 separate lines, even though that's the default formatting. So on awake, we want to calculate our that whatever our max touch dist will be. So max touch dist will be our max touch fraction multiplied by our screen dot width. And our screen dot width will vary from, device to device, screen to screen, but because we are taking a percentage of the screen as being our maximum distance, then no matter what screen resolution we're on, we can always, it'll always be something, reasonable. So actually in our inspector, because we've used the range, it gives us this slider which actually limits, which is just handy, especially if you have other people looking at your code, or if you just can't remember later down the track and accidentally set it to a value it's not supposed to be. So I'm just going to set it to 0.33, which is approximately a third of the screen. So the user will only have to drag their finger across the third of the screen to achieve maximum power. So let's go back to our code. So now we can start calculating our distance. So our distance will equal, and we're going to use a mathf clamp, because what we're going to be saying is basically dist equals dist plus get xpos delta. And so we're going to be constantly adding every frame the distance. But the thing is, we don't want our distance to be getting greater than 1, or whatever the total value is, and we definitely don't want it going lower, going negative. So for that we can use something called mathf.clamp, and takes 3 parameters. So one parameter being the value, which is distance plus, and then it will be we want to keep it as a value between 0 and max touch distance. So now we know that the value, so distance will equal distance plus plus the delta, and we know that it will never be over the max touch dist, or never negative, which is very important. And something we also want to make sure that we're doing is that each time we touch down, we just want to make sure that our distance is back to 0. So distance equals 0. That's also very important. Also, we need to make sure that we have our last touch position actually has a value to start off with, because when you load your level for the very first time, or each time at the start of the game, last touch position is not going to have a value to start off with. So if we didn't call this, then what would happen is that we would call this method, and then straight away we're asking last touch position x minus this value. And then what's happening here is, then last touch position doesn't have a value, or by default it's going to be 0. And we definitely don't want that to be 0, because otherwise last touch position doesn't get set until this line is called. So what's basically going to happen is that the first time when we click down in the first frame, the last touch position will equal the same as the current mouse position because it's on the same frame, which means that the difference will be 0, so nothing will happen on the first frame, which is what we want. And then it will save the touch position so that the next frame when it's called, last touch position will have the position of where the touch was previously, and then now we have our new touch position for this new frame, which should be, you know, somewhat of a difference in distance. And then finally, for our third input, sliding the burger, we will need a method for this. So what we can do is create a private void, and we can just call this you know, slide burger, and we're going to take a float called fraction. So when we release, we're going to say slide burger, and to get a fraction between 0 and 1, we're just going to divide our distance by our max touch distance. And this is pretty straightforward. We're just going to add force to our rigid body, and we're just going to take the transform of the burger and add force to the right, and then multiply that by and we'll need our maximum power. So let's make a public float max power. So let's multiply max power, because then we're then going to multiply it by the our fraction, which is fraction. And then we'll also give it a force mode of impulse, because we want our force to be you know, instant essentially. Now, just like a little kind of thing about this is that if the user doesn't really know how the game works that well, or accidentally touches the screen just like a little bit, then what can actually happen is that if they just, you know, power the burger slide just ever so slightly, then what can happen is that the burger will just slide, you know, very slowly, just a tiny bit. And so then what that does is that kind of creates problems for the way that we are going to detect whether the player has whether the burger has been slid or pushed, because we need to check that. We need to check to see if the burger has been, you know, launched, so that we can then start waiting for it to slow down, and then once it slows down and stops, then we can check to see whether it's at the end goal or not. But the thing is that to do that, we need to check to make sure the burger has exceeded a certain velocity, to make sure that the burger has, you know, has been launched. And so if the player just does like launches the burger just ever so slightly, they're going to be able to move the burger without without triggering our check to see that they have actually launched it. Because if our check is too low, if our velocity threshold is too low, then what will happen is it will fall under our velocity checking whether the burger has stopped. And so then basically as soon as the player tries to slide the burger, it just ends up resetting. And yeah, so just as a way of just preventing this little thing from happening, we can just simply set up a minimum kind of fraction. So we'll create a public float min frac, and if you wanted to, you could even give that a range as well, like that. And for our fraction, we're going to use the same mathf dot clamp, and we're going to be clamping the fraction between our min frac and maximum of 1. And for our min frac, we can probably set that to just 0.1. And for max power, let's just try 10 for now. Save that. I think we're at a point where we should create a prefab of our burger. So let's just drag our burger in here. Okay. Oh, something I just forgot is we'll just check to make sure that the player actually, so when they release their finger, we want to check to make sure they've actually dragged their finger anywhere, and so that way the player, if they wanted to, they can drag it left, but then if they drag it all the way to the right, they can bring the distance back down to 0 and then let go, and it's not going to slide the burger. So we just want to check to make sure that distance is greater than 0 before doing this. So now I think that is ready to test. Let's set up. Actually, I think our camera is fairly okay. We can maybe, yeah, I think our game camera is in a fine position. So now if we hit play, actually, you know what we'll do for now is in our update, what we can do is actually on here, we can just debug.log our fraction multiplied by our max power. So you can see all the way up to 10. Now I'm still moving my mouse, see, still moving my mouse. But as soon as I start moving my mouse to the right, power starts to go down straight away. You can see in the bottom left there in our debug. Right, and all the way to 0, and I can move my mouse all the way, still holding on, all the way to the end, but as soon as I start moving it left, the value starts to go up again. Let's let go. Oh. So yeah, we'll need to start playing around with the physics of our burger in terms of physics materials. So for that, we'll create a folder. We can call this physic. Does that have a space? Oh yeah, physic material. And we're going to create two physic materials. Not material, physic material. We can call this one. Oops. We can call this burger physic material. And we'll create one for the toppings as well. Topping physic material. Okay. Now for our toppings, we basically want it to, we want to try and reduce how much influence our toppings have on everything. So we just want to set everything to 0. We don't want any extra kind of physics going on. And if we set that to multiply, then it's just going to make sure that it is not going to be having any kind of anything other than 0. Now for our burger, we'll set this, we want a little bit, just an ever so slight amount of dynamic friction. So dynamic friction is just how much friction it's just going to have as it's moving. And then static friction is just going to stop it from sliding if it's already, at an initial standstill. And then we're just going to make sure that we have the minimum for those values, because the default is greater, and that this surface, any kind of object you make, like any kind of block or cube or whatever, is going to have a default. Any collider is going to have a default material, physic material associated with it, which will just have default values. And so we just want to, by using minimum, if we know that the values that we set are less than the default values, then it's going to be using our values because they are smaller, therefore, because we've chosen the minimum. Now to assign our physic materials, we just drag our burger physic material to our burger, and then we can just select all of our toppings and drag in our topping physic material. Now something we can also do to make our burger more stable is to make sure that it has a bit of angular drag, and that's just going to help prevent the burger from turning and spinning around too easily. We want the burger to turn a little bit, but it's just gonna help prevent that from happening too much. So we'll set our angular drag just to 1, and for all of our toppings we'll just leave the angular drag to 0, because we don't want those messing with our burger too much. Okay, so let's we can set our aspect ratio to 16:9. And let's see. Oh, not I want the whole burger. All right, so let's move our burger to the left. Okay. Close that tab. Like that. And there we go. So now you can see our burger is sliding and it stops. Now it takes a lot of time to play with all of these physics settings to try and get the right physics that you're happy with, that does what you want it to do. You can always tweak it and play with it, but it does take a lot of time, a lot of just experimenting and practicing and all that kind of stuff.